Hello everyone. I wanted to kind of go over this problem again, and I know some of you are having issues and you're trying to do your homework, so I'm going to try and make this quick video to try and help us out. So I have this apparatus, and I know that each one of these chains can support a maximum tension of 600 pounds before they fail. So what I need to find is what force I can pull on before one of those breaks or fails. So what I'm going to do first is I want to draw my free body diagram. And I'm going to let's go ahead and change colors on that. I'm going to try and draw this so it looks somewhat decent. So this is going to be 30 degrees. And then I'm going to have TAB, and we know that's going to be 3, 4, 5. So that's going to be 3, 4, 5. And then I have my last vector coming over here, which is going to be the tension in AC. So if I want to go ahead and sum my forces in the y direction. So all I'm using is my equilibrium equations. So when I sum my forces in the y, I'm going to have TAB here. So that's TAB times, now I'm going up 4 over 5, so that's going to be 4 over 5. And then I'm going to subtract, because this is going down, this vector going down right here. So it's going to be minus F, and that's going to be sine of 30 degrees. And of course, that's all going to be equal to 0. Now, I'm going to sum my forces in the x, just as I did in class. So you'll have all this information that we did in class if you didn't erase it. So I have TAC, which is going to be positive, and then I'm going to have plus TAB times 3 over 5. That's also going to be positive. And then I have my force, I should have labeled that, my force, which is going to be a negative force times the cosine of 30. So what I really need to do is I need to look at finding two equations and two unknowns, or seeing if what other things I can do to solve for this force. So one thing I can do is I can come out and say, alright, I'm going to look at this equation here, and I'm going to see if there's anything I can do with that equation to solve for TAB. So if I just manipulate this equation and say, okay, TAB is going to equal, and now I take this force sine 30, I take that to the other side, so I'm going to have force times the sine of 30 all over 4 over 5. So that's what I'm just solving for TAB. So TAB then is going to equal 0.625 F. So all I've done is manipulated this equation to solve for TAB in terms of TAB. So I can substitute TAB into here. So all I'm going to do is take this and substitute in right there. So I'm going to come in and say, alright, so I'm going to have TAC plus, now I'm substituting 0.625 times 3 over 5 times F. So all I did again was substitute in here. Alright, so TAB is now F times 0.625, and I put 3 over 5. I may have put them out of order, but that's right. Minus F times the cosine of 30, and this should have equal to 0, so that equals 0. So now I can manipulate this equation to solve for TAC. So if I add 0.625 times 3 over 5, and I subtract cosine of 30, then TAC is going to equal, just by combining like terms, 0.491 F. And TAB over here, TAB, we solved for as 0.625 F. Now how does this help me? Well, I know that the maximum tension is 600 pounds before it fails. So what I can do then is I can just come over here and substitute 600 pounds here and 600 pounds here. So I land up with 600 pounds is equal to 0.491 F, and and 600 pounds is equal to 0.625 F. So simply I 0.491 divide that 491, divide this by 0.625, divide this by 0.625. So F in this case is going to equal, plug that in my calculator, 600 divided by 0.491, 600, enter, 0.491 divide, I get 1222. And then down here I'm going to divide 600 times 0.625. That comes out to be 960. Now, if I put in a force here, right there, of 1,222, well, TAB, this one will be okay, but TAC would fail. So we'd have to look at is the force then is 960 pounds of force that we could use in order for this not to fail. If we use anything greater than 960 pounds, those cables would fail. So I know this was a quick and dirty, and I know this was the issue that we had in class, or that I had in class, and how I got there to there. So I hope this helps clarify a few things. If you have any questions, just let me know. Thanks.